Alright, so that one, that one, that one, that one. That one's out, that one's here. That one's out, that one's here. That one's here. That one's here. That one's here. Here. That one's here. Down there. That one's here. Okay. Cool. Okay. Turn it into a graph. Make sure it's sort of neat, sort of labeled. Graph paper's better. Okay, we're going to start doing a lot more with graphing. So, as of next week, y'all do it on graph paper, or we ain't counting it. If you need graph paper, there's always some up there. You can always just Google printable graph paper if you just need a piece. Or, you've got $1, I got notebooks up there. Same as if you were going to Walmart, except it's more convenient because it's right in your classroom. Okay. Trust me, counting boxes instead of trying to wing it based on your scale, it's going to be a lot easier. Anyone still going? Cool. Stage 1 graph. I've got myself 10 boxes in both directions. I need to fit through 4 on the x-axis. Can I go by ones? Yeah. Can I go by halves? You can. Did anyone? No. All right. So we'll just label our x-axis. It's got no words with it. It doesn't have any other meanings, just table. I've got my y-axis, 12 to 16. I've got 10 boxes. Who went by 2s? Who went by 1s and just had a big graph? Okay. Who used the little lightning bolt thing in there to jump up? Okay. All of those are viable. You could just say, I'm going to start actually, instead of there, at 12. And then 1, 2, 3, 4, 13, 14, 15, 16. You can do that. So if you do it that way, you make your dots, you're good to go. If you make it with words, go by 2s. If you just make a really big graph, everyone's got their own jam. What you got to make sure is, do you have it labeled? And then did you actually plot the points? Got 0, 12, 1, 13, 14, 15, 16. Okay, as a graph, check. As a equation, Well, because it is linear, that means I'm able to write it in that form. Y equals rate x plus start. And I can only use that form if it's a line. If it's not a line, then you got to think about something else. Like we ran across something squared. We ran across, what was it, absolute value? We ran across some different critters last time. This one's line, so I just go with this. And say, where'd you go? Y is my rate. How much does it change every time? Uno. So 1x. Remember, I don't need to write the 1. If you wrote the 1 on there, I'll take it. But you don't write the 1 normally. It's not considered simplified if you do. For now, we're still learning. I'll leave it. Start. Remember, the start is always when x equals 0. So just 12. Y equals x plus 12. There you go. Do you have a linear equation? Even if it's not the correct one, do you have a linear equation? You didn't put x squared. You didn't put absolute value of x. You didn't try to throw random fractions in there. You got a linear equation. You got the correct linear equation. You have the right rate, the right start. You've got the correct points plotted, and you have your scale labeled on it. Whatever scale you chose. You went by 2s, you went by 1s, and from 0, you did a little lightning bolt up to 20 or 12. Whatever your jam was, you got it labeled. They are the correct points. Anyone else in this room can pick up your paper and know what those points are. And then, did you say that it was linear? Okay, because that was one of our questions. So 2 for the equation, 2 for the graph, 1 for saying it's linear. What you got out of 5? You got questions on scoring it up?
So if I didn't put my x and y, then
Did you label, in this case, they don't have word labels, so we know it's the x and y axis, and that's fine. Do you have the numbers on there?
yes.
There you go. Good enough. Now, if this was actually labeled in the table, if x was number of impaled frogs and y was number of sadistic children, then you would need to label those on the side of the graph. Okay? You know, if you do impale a frog, they got a really big tongue, so they go, their tongue sticks out.
That's what my dog does. He sticks out his tongue a lot. It makes him look
Okay, I thought that was going somewhere really dark, but okay. I thought you meant you impaled your dog. I was like, what? Redheads. Never know. Okay, score them up. What was the random word problem last time? It was like you and Elena were serial killers or something, had grandma stuffed in the icebox. Just nonchalant, yeah. Okay, homie work. Talk to me, Goose. Yes, ma'am. I heard 14 and 20. Well, yeah, I mean you're still following along, right? 14. Ew! Fractions. Did we not do 14?
Yeah, why is someone doing 14?
I mean, if you did 14, well, I think we can figure it out. X's go 1, 2, 3, 4, 5. I don't care whether we did it or not. It's still good practice for today. 1, 2, 3, 4, 5. 2/3, 4/9, 8/27, 16 81sts, 32, 240 thirds. As the youth say, that escalated. Okay. Does anyone know what you're doing each time? What if I broke it down and said, just look at the numerators? 2, 4, 8, 16. Okay? The top is being multiplied by 2 every time. The denominator, 3, 9, 27, 81, 243. The bottom is multiplying by 3 every time. So every time I multiplied by 2 over 3, 2 over 3, 2 over 3. And we said, what is repeated multiplication? I heard it. Someone whispered it. Starts with an E, ends with an exponent. Right? Repeated multiplication is an exponent. I kept taking 2/3, 2/3 to the first. 2/3 to the second, you square both parts. 2/3 to the third, square both parts. Or cube both parts. That's it. That is the equation. Done. I kept repeatedly multiplying 2/3. So 2/3 to the x. What was the other one I heard? 20? 20, 15. Well, 15's right there, so we'll do that. Okay. 1, 2, 3, 4. With 2, 16, 54, 128, 250. Get down here. All right, the first thing you check, is it linear? Because that's where most of our stuff is going to be. It's linear if their first set of differences is the same. From 2 to 16 is add 14. From 16 to 54 is not that, right? So that means it's not linear, because it should have been adding the same thing every time if it was linear. All right, it's not linear. I have to think about something else. What do all of my y's have in common? They're all even. What would happen if I divided all of those by 2? Just throwing out an idea here. They're all even, so divide them by 2. 1, 8, 27, 64, 125. I hope those numbers look familiar. Okay, I know you're all the way down in algebra half, but your high school career will be made all the more easy if you know your perfect squares through 20, perfect cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on. Everyone got a calculator on hand? If you don't, why don't you? You're in a math class. Now, you're not really going to hammer into exponents until next year. Maybe if we do good enough this year, we can get to it early. Like exponent properties, really big exponent expressions. But please tell me you all know where your exponent button is, at least for middle school. Or a box to the box. Or a caret. Y'all see those buttons somewhere on your calculator? What's 3 to the third? 4 to the third. 5 to the third. These are all x cubes. So if these are twice as big as that, 2x cubed. You look at what do they have in common. Well, they're all divisible by 5. Okay, divide it by 5 and see if you can find the pattern. It's kind of like you ever see the old metal detectors? Everyone ever see someone at the beach with one of those? Okay, they take out this big lump of crap. Well, not actual crap, but they get this lump of stuff, dig it out in the ground, it's all rusty and everything. If it's about this big, is that a gold coin? No. Get some crap off of there and then figure out what it is. If it's about this big, is that great grandpa's wrench that I was looking for? Well, no, it should be like this. You clean some of the crap off of it. In this case, they're all divisible by 2, so divide them all by 2. Get some of the junk off of it and see if you can see the pattern. See if you can see what it is after you get rid of the extra stuff. And the extra stuff might be they're all divisible by 2. They're all over 3. They're all decimals that end in 0.5. If you see that pattern, add, subtract, multiply, divide, something to try to bring them all back to the numbers that we should be familiar with. I honestly didn't expect anyone to get 15. What I expected was that someone would have asked. Remind exists. Spartan time exists. You have time right after school. You were in White 4. Okay, please ask. Last semester, we had more than half the class decided they just didn't need to do any of their work. It didn't end well. Was there a 20 or was I imagining that? There was a 20? Okay. Nope, next page. Okay, designer wants to make a circular fountain inside a square of grass, shown like this. Like the one over by Brady Park. There's a little like fountain there, and kids jump in there even though they're not supposed to, especially when it's like neon green slimy in there because they never clean the filter, right? What is a rule for the area of the grass? So just the shaded part outside of it. This is asking you to remember stuff from middle school about basic area. Do you know how to find the area of a square? How? How do you find the area of a box? Length by width, right? And if it's a square, this side's 2r, then that side's 2r. So the box is 2r times 2r. Length by width, also called side squared. Okay? Do you know the area of a circle? And if you don't know it off the top of your head, several of you got your books out. To the back, the ancient magic says we put knowledge in books, like a formula sheet somewhere in the back in those yellow tabbed pages that say reference. Somewhere in the back, in those yellow tab reference pages, you should have a big old formula sheet. And it gives you a bunch of this, not index, not solutions, yellow, reference. It was where we had all of our conversion tables. Right? There we go. Yellow, reference. We're in chapter 4. There's all of our stuff. Properties, formulas. Where's my big formula sheet? Reading math symbols. There's all of our metric units. Odds. Ah, there we go. The very end, page 820. Area is pi r squared. Okay. Yeah. Radius. The diameter is all the way across. Radius is halfway from the center to the edge. So like radius would be, I've got this tube here that's about 2 feet long, 24 inches. So the radius of that circle was 24 inches. But if I can get it going fast enough, nope, because now it bends in the middle. Then I'd have 24 inches going both directions. The diameter would have been 48. Okay, so just seeing if you remember stuff from, well, middle school. If not, can you look it up in a book? Can you Google it? Okay, use your resources. Now the question is, if I only want these shaded pink areas, do you remember how? Doughnut problems. When you move on to geometry, you're going to see them often enough for geometric probability. Squeak, squawk, squeak, squawk. You're going to have the big thing minus the thing you don't care about, right? The whole donut, subtract the donut hole. That's the area of the donut. In this case, the entire square minus the circle, because that's the fountain part. If I have 4r squareds minus pi r squareds, well, that's 4 minus pi r squared. Same as if that was 4r squareds minus 2r squareds. You'd say 4 minus 2. Well, it's 4 minus pi. When they ask, what is a rule for the area, I would accept either this or this. It just said a rule. A rule means an equation. But we had to go back and look some stuff up to find it. Okay. You have typically 48 to 96 hours between classes. It's plenty of time to ask a question. You're in the middle of your homework. I don't know how to do this one. Picture of problem, send to teacher. Teacher is not beset upon by toddler goblins. Teacher answers. That's how it works. Okay? I don't care if you're doing your homework at 10:30 Sunday night. Finally. Send me the picture. The next morning around 5:45 when I'm chilling on the couch watching Encanto for the 98th time, Baby Bear's sipping on chocolate milk, I'm going to see the message and I'm going to sketch it out and send it to you. Okay? We don't talk about Bruno. What do we got? Anything else? Yeah? 12. No joke. I've watched Encanto an average of twice a day for the last 2 weeks. Baby Bear's a little bit fixated on it. For the diagram below, it says, here's your figures. You have this many triangles and this many small triangles. Represent the relationship with words, equation, graph. Fill in the table. Round 1. Can you see the pattern? 3 to 12 to 27. What is the pattern? What are they doing every time? Well, they're not adding the same thing, because then it plus 9 and then plus 15. That doesn't make sense. Maybe I just draw more triangles. Okay, so here there's one of them. Here's 4 of them. Here's, well, there's my original 4, and then they added 5 more. There's 9 of them. 1, 4, and 9 should look familiar. They're all what kind of numbers? Well, they're not all odd. Not 4. Square them. There you go. So the next one, oh, wait a second. Figure 3 was 3 squared. Figure 2 was 2 squared. Figure 1 was 1 squared. That many triangles. So the next one, figure 4, is going to have 16 of these little triangles, and each of those triangles has 3 little ones inside of it. So the next one after that will have 25 triangles, each with 3 inside of them. Because 5 squared, 25, and then 3. The next one would have 36 triangles, 6 squared, and then triple it for all the little ones. And it keeps following that pattern. So 4, 48, 5, 75. And if I recognize that each one of those is divisible by 3, just like our, not daily quiz, the one we just did before that, if I divide each of these by 3, I get 1, 4, 9, 16, 25. So yet again, I clean up the crap. They're all divisible by 3. Okay, that means I'm going to be taking 3 times something. That something was this number squared, that number squared, that number squared. There's my equation. And then I'm pretty sure y'all can do the graph by now. I hope you can do the graph, because that's kind of what we're doing today. Find a reasonable scale for it, plot points. Okay. I hope everyone has their own calculator. If you do not have a calculator in front of you right now, you will need one, because I'm going to help you to not have to write so much. Okay. 4-4 is an extension of this. It's where we cross the boundary from here's pictures, make a table and a graph and an equation, to I'm just going to give you the equation, make a table and a graph. This is the fallback option. Okay? When I say the fallback option, I mean in every other class, where is that? Where's Algebra 2? I don't actually have any of the graphs shown. Fine, we'll do these guys. Every type of function that you can run across, whether they are familiar or not, these, they're coming. We'll see a tiny bit of them. We'll see their like elder dinosaur cousins today. This is a review problem in pre-calc. You first see it in Algebra 2. All the way up there, we still run across equations that you cannot graph just by knowing how to do the thing. You have to graph it by table. I hope you saw this before, back in middle school at least. Negative 2x plus 1. If I'm going to graph y equals negative 2x plus 1, the easiest way to fall back on is graph by table. Please tell me you have seen something like this before. Yes, no? Oof. Okay. So, put that next to the table. And the way that we start these is by picking numbers, usually right smack in the center of the graph, so we can see its behavior. The most commonly used, 4, 4, right next to the graph. You don't have 4, 4?
Didn't you say that you
it's like half.
like when you gave us these packets and you said that you didn't have any time yet?
Ah, hell. There it is. So I got the notes, you don't. Debating how I want to. Take the easy route. Go old school. Everyone needs graph paper. You'll just staple it on the back, call it 4, 4. Next time you come back, I'll have the rest of the packet there for you. Got your own? Cool. Got your own? Cool. Got your own? Okay.
Yeah.
Huh. No. No, that's the only way that Game Club has any funds is we sell food to impulsive teenagers.
Yeah.
Okay. So, here's how you do it. I hope you have, once upon a time, taken basic notes in a math class. Top of page 4, graphing a function rule. Okay. I'm printing the notes out just because it makes life easier for you. I don't have to. I just forgot because we had stuff to do. Okay. Right under that, you put problem 1. And negative 2x plus 1. Right? It was negative. Okay. make this little table and leave yourself room to work. X, -2 with parenthesis x plus 1, y. Okay. Graphing by table is, that's like your nuclear option. If there's some ants in your house, you call an exterminator. If there's a mouse in your house, you call an exterminator, or you put out rat traps, or you do this, or you do that. If there's a badger in your house, like, every time there's a little bit different solution. Is the solution possibly burn the whole house down? That's the nuclear option, right? Just burn the whole house down. There's a spider, kill it. This is the nuclear option. This is your fallback every time you run across something you need to graph. You have no clue how to graph it. I have no idea what this thing does. I don't know the rules for it. I don't know its pattern. I don't know diddly. But I know how to make a table with -3, -2, -1, 0, 1, 2, 3, right smack in the middle of the graph. And I can plug those numbers in for x to make the table. See, last section, they kept giving us the table, or at least the coordinates. This time, I'm going to make the table from the equation. And I do that by, remember, I'm plugging in x. So next to each one of these is -2 parenthesis plus 1. -2 parenthesis plus 1. -2 parenthesis plus 1. This is your nuclear option. This is your fallback. This is, I'm stuck and have no clue what's going on, but I can do this. Walking up to your house with a flamethrower might be overkill if there's a raccoon. But it'll get the job done. Okay? You said x was -3, so plug it in. What's -2 times -3? +6 plus 1. Ta-da. Plug in -2. -2 times -2. 4 plus 1. Plug in a -1. Plug in a 0. Plug in a 1. Plug in a 2. Plug in a 3. And pretty quick, you see the pattern to it. 2 plus 1. 0 plus 1. What's it doing every time? Down by 2. Fill out the rest of the table. Down 2, down 2, down 2. What's down 2? What's 1 minus 2? Minus 2. Minus 2. Ta-da! Plot points. You use the table to find the points. Now that you have the points, you have the ordered pairs, the coordinates. Now, my table doesn't, or my graph doesn't have room for all of them. That's okay. I need to graph at least 3 points to make a line. So, -2, 5. Please tell me you know this. Please tell me you know how coordinates work. Okay? X is left and right, Y is up and down. At the very least, if you play video games, you got to know that. Invert Y-axis on shooter games. Okay, not like get hit with an EMP, now everything is swapped, so left goes right, right goes left, all that. But invert your y-axis allows you to, I learned that from playing fighter games. Rogue Squadron, Nintendo 64. Okay. X goes left and right, Y goes up and down. So this is at a coordinate of -3, 7. Back 3, up 7. I don't got room. Maybe you do. I don't. If you got room, plot it. If you don't got room, don't. But -2, 5, I've got room for that. Back 2, down 5. Back 1, up 3. That I did the wrong way. Whoop. Sorry. Back 1, up 3. 0, 1. So no left or right, up 1. 1, -1. Right 1, down 1. Right 2, down 3. Right 3, down 5. I got me plenty of points, and I hope at the bare minimum y'all have a straight edge like a... How do you get in the building? You got to have some sort of straight edge with you. I've had kids use the edge of their phone case if it's straight enough. Dairy Queen gift card. Okay? I don't care. Use something that's a straight edge to connect the dots. What I don't want you doing is just winging it. Because some of you, let's be honest, your handwriting and your artistic skills are not exactly the best. Okay? Now me, I want the more points the better, because trying to draw it up here, I usually wobble. I don't always hit the points. I'm trying to draw on something that big. Okay? This is how you're going to make a graph by table. It makes life, well, I wouldn't say easier. It's tedious, but it works. See if you can plot this one. Yeah, it's got a fraction. You can take a half times something. Be not afraid. Make your table. You have your x's. You've got your y's, which are going to come from 1/2 x minus 1. Fill in the table, plot the points. Now, if you know how to graph by slope-intercept, that's great. I already looked at your assignment. They ain't all linear. You better know how to do it by a table, because what happens when I throw absolute value, quadratic, and cubic at you? Can you still do it by the table? Okay. This is our fallback option. If you're going to use the nuclear option, if that is the option available to you at all times, you should probably practice it. If something is on fire, I should probably know how to use an extinguisher. Have you ever actually practiced using an extinguisher? You know, something like 80+% of people don't actually know how to use a fire extinguisher because they think it's just like in the movies where you just point it at it and fog it. That does nothing to it. It's supposed to have a sweeper action coming at it from the base. Have you ever done that? Okay, you need to practice the table version so that when it's an ugly equation that you don't know the tricks for, you can still do it. What happens when number 4 on your quiz next week says, make a table and graph, and you decide you're not going to make a table because you don't want to? Well, -3. Okay, you didn't do the thing we're assessing. Make sure you know how to do it. Okay, everyone's going to run at a different speed. Okay, you set up all your parentheses there. You're all ready to roll. Put in. Actually, get the right color scheme going. Half of a -3. -1.5 minus 1 is -3, 4, 5 halves. What is it? 7 halves? 12 halves? Okay. I hope that we have -5 halves. Definitely my preference. But if you have -2.5, that's okay, because it was a terminating decimal. Okay. -2 by a half is -1. -1 minus 1 is -2. Is -3 halves is -1. Is -1 half. Is 0 is 1 half. Okay. -5 halves. It was a little squishy. Plot points. Back 3, down 1 half, 2 half, 3 half, 4 half, 5 halves. Back 2, down 2. Back 1, down 1 half, 2 half, 3 halves. -1. -1 half. 0, 1 half. You've got enough in the middle of the graph to show the pattern. Yes? Mm.
Like for the first one, I got -0.5.
Missed a negative here. So instead of -2.5. That's it. Just missed the negative. Y'all, please tell me you got a right view calculator. At the very least, you should have a right view scientific coming into high school. There's different flavors of them. Okay. These Casios. They're like $11 at Walmart. This will almost do your taxes. 36 Pro. If money's an issue and you know you need a calculator for the next 4 years, $18, and this will do almost everything you need to in high school. This will do parts of calculus. This will do regression models from Algebra 2. 18 bucks. Okay? Like 10 bucks. Okay? These ones. These have been the trusty standby for probably 25 years. I love these things. This is like $8. Does it just fine. The reason I say that is we can do all of this by table by saying negative 1/2. I bet most of you just said negative 0.5. Parenthesis, negative 3, parenthesis, -1 or +1? -1? Okay. If you have a right view calculator, right view means that you can type it the same way it's written, including with fractions. If I said, instead of negative 1/2, it was negative 1/2. Okay, you've got a bunch of different options here. If you're going to use the bumblebees in class, alpha y equals brings up a fraction menu. A negative 1/2, parenthesis, negative 3, -1. Okay, one of them says 1/2, the other says 0.5. One is because I have a fraction, the other is because I wrote it as a decimal. It'll do it the way that I told it to. It makes filling in the table super quick. Highlight it, turn it to a -2. Highlight it, turn it to a -1. You can do this on any right view calculator. If you're on one of the fancier ones, then I can say negative 1/2 x minus 1 as an equation and just go to my table. And it'll do the table for me. In fact, once kids come up to Algebra 2, I tell them never make a table again. Now, you're a couple years off of that. We got to learn the hard way because this is our fallback option. You take pre-ACT, ACT, Smarter Balance. They don't give you the calculator for all that. Or sometimes they won't even allow you for certain sections. You have to know how to do things. Okay? Put your straight edge on there, connect the dots. Yahoo, there it is. The reason you need to know this is sometimes you can't just do it because you know mx plus b. Sometimes they're big ugly numbers. Well, you better know how to make the table. Okay? So, y'all doing this old school, then you write example 2. Here we go. The function rule, W is 146C plus 30,000 is the total weight in pounds of a concrete mixer truck carrying C cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph for the function? Well, step 1, I'm going to make a table. Does the weight depend on how much concrete I have? Or does the amount of concrete I have depend on how heavy my truck is? Okay, so that's my independent and dependent variables. My weight depends on how much concrete I have. Okay, I'm going to put C in and get W out. Input, independent. In the middle, that's where our work is going. It's 146 C plus 30 grand. Now, when I choose numbers for this, does it make sense for me to go back to -3, -2, -1? What is C? Read the problem. No, W is weight. Cubic feet of concrete. Okay, like one of those ready mix bags. Okay, a cubic foot of concrete is 1 foot by 1 foot by 1 foot. 1 foot by 1 foot box. Okay, this is more than a cubic foot. So each one of those cubic feet, one of those little boxes of concrete, is 146 pounds. The truck starts at 30,000. And every one of these little bit of concrete, this much concrete, adds another 146. I'm betting that it carries a lot of concrete. So, reasonable numbers probably don't include negatives. I can't put negative concrete in there and make the truck lighter. Doesn't work that way. So I'm going to start at 0. 0 is reasonable. Now I'm betting they're not just going to add in 1 foot of concrete. 1 foot of concrete. 1 foot of concrete. You ever seen a concrete truck? Mixer truck? They're huge. Maybe they put in what? 10, 20, 50, 100? They put in quite a bit. So let's go. What do you think? Okay. Read the rest of the problem. They said something about the concrete. 200 was our max. So I need to go from nothing to 200. How do you want to split it up? Going by 10s is probably overkill. 50s? I'd say I'd probably have enough points there. 50, 100, 150. All right. Fill it in. 146 by thing plus 30,000. 146 by thing plus 30,000. And in each case, you are plugging in 0, 50, 100, 150, 200. Grab a calculator. Let the calculator do the heavy lifting for you. Every one of your calculators, all the way down to the dinky one on your smartphone, has parentheses. What's anything times 0? Plus 30,000. 30,000. 146 by 50. Say 146, 50, plus 30,000. And write it. 37,300. Do it again. But now we're going to put 100. Okay, y'all know how if I type 0 right now, it overwrites that parenthesis? You probably had this happen to you a bunch of times where you go to type something and then, crap, I just have to retype the whole thing anyway. Insert. Find INS, insert on your calculator. And boy, is that a lifesaver because it just says go put it in between there. Saves you time. Okay. 44,600. If you got a right view, you can just go up and highlight the thing, then change the part you want to change. It's either that or you're hunting and pecking, taking a lot longer with it. Highlight the thing. Now, right now, we're going to want the work in between. Baby steps. We're just starting. It's algebra half, not algebra 1. We have to start somewhere. And that means showing the work so we remember what we're actually doing. Now, later on, after we get a good handle on this, we'll probably be okay to just type it on our calculator and only write the blue and purple parts. Today, day 1, step A, training wheels, we're going to write the middle. So we got the work to back it up. Cool, I got a table. I got a grid space. I now need to make the graph. What is a reasonable scale to use on the bottom? I've got, well, whatever space you have, right? Just go by 50s. My graph will only be 4 spaces wide. I could go by 10s, 20s, 50s. Maybe I cut the difference and say by 25s. You'd have a point every other. Okay. However you're going to do it. Now me, I want to use this whole space just so you can see the graph nice and big and pretty. So I'm going to go by 25s. I just feel like it. And we're going to say C is concrete in cubic feet. We start at 0. And then here's going to be 25. Do I have enough? 25, 50, 100. Nah. Okay, 25, 50, 75, 100, 125, 150, 175, 200. So it'll take up a good chunk. 250, 300, 350. My y-axis. Well, if there's no concrete in it, the lowest that the weight ever goes is 30,000. I probably don't want to start all the way down at 0. So I'm going to use my little lightning bolt and start at 30,000. And you know what? I'm actually going to just write 30. Because there's a nice little trick with this, and I'm sure you've seen it. In your labels, you say in thousands. So this is weight in thousands of pounds. So 30 on the side, so I don't have to keep writing all the other numbers. 30,000. Right? The label takes care of it for me. Less numbers to write. So I need to go from 30,000 to at least 59,000 and change. So from 30 to 60. What do you want to go by? You tell me. Probably doesn't make sense to go by ones. Doesn't make sense to go by tens because then after only 3 boxes I'm already at 60,000. Okay, by 5,000? Okay. So here's 30,000, here's 35,000, 40, 45,000, 50, 55,000, 60. I'll just finish off the graph because this will help me extrapolate. Plot points. And we're going to have to guesstimate on some of these because my scale is so wonky. Okay, so 30,000, 30,000, that's easy peasy. But when I'm at 50 and then 37,300, where is that going to be? Okay, so at 50, in between 35 and 40, and 37,300 is going to be about halfway. Fill in the rest. At 100, 44,600. So just a hair under 45,000. At 150, it's 51,900. So right above 50. 59,200. So 200, 59,200 going to be right under 60. And if we made our scale right, if we winged it decently enough, we should be able to put our straight edge on there and hit all those points, or really, really close. Kids often ask throughout their high school career, when am I ever going to use this? There's a reason that Algebra 1 is the minimum requirement for a diploma in high school. Understanding basic stuff like how do I make and read a graph? How do I interpret it? It affects your decision making as an adult. If you can't read the graph, if you don't know how the graph was made, if you see a graph that looks like it's favorable to you, but it turns out it wasn't because the scale was different, that can really mess with your decision making. Companies use that all the time to basically take money from you. Okay. Some of the most famous ones I've seen, there'll be a company that shows like this. They'll say, that's us, and this is our competitor. You're like, well, clearly, I mean, they're better in everything. Are you going to recognize the fine print on the side that's like that? It doesn't make a difference. Like, it's literally 0.1% or a 0.100%. Here we go. It's done the exact same way. Make a table. Make a table, make a graph. Have a reasonable scale. Okay? It's set up the same way. The equation's even set up the same way, where instead of C cubic feet of concrete, it's G gallons of water. It's set up the same way. Make a table the same way you did last problem. I never did attendance. Did I? Yeah, I did. Oh, yeah. Set up the table the same way, but you got to pick what are reasonable numbers to put in. They told me the capacity again. Last time they said my truck can only hold 200 cubic feet of concrete, so we only went to 200. Told me how to split it up. What does this one say? How are you going to split that up? And deciding how to break up an amount. It's a life skill. You want to sell your own art. Open an Etsy shop. I need this many bubble mailers. I need this many bags of packing peanuts. I need to order this many of my custom sticker that I put on all my stuff. There's a lot of people in the last 2 years who left the workforce and did their own business. Got to figure this stuff out the hard way. If you're a little fuzzy on terminology, when they say spa here, it's a hot tub. Not like the entire spa where they spackle your face and trim your nails and that kind of stuff. Okay? It's a hot tub. Like jacuzzi is just a brand. All hot tubs are not jacuzzi. Chat it out with your neighbors. Shouldn't be this quiet. What are you using for a scale? Is your neighbor using a similar scale? Are you even attempting to do it, or are you just waiting to copy it and make it look like you did something? And when you finish it, it should look like a line. This is a linear function. So if you did it right, your points should make a line. Okay, if you're brain farting on what to do here, what is the capacity? How big is it? How much water does this thing hold? 3 ounces? 40 liters? What? 250 gallons, right? It says it right there. If I have 250 gallons of possible water to dump in here, how should I break that up to go from 0 water to 250? What do you want to go by? Tens? Ones? 40s? 50 seems pretty reasonable. Which means I need another one of these. Now we're probably going to see the pattern where we don't have to do the hard way in the calculator pretty quick. If I'm plugging in 0, 50, 100, 150, 200, 250. Anything by 0 is that 0 plus 700. 8 by 50 plus 700. 400 plus, and then 800 plus 700. And then 1200 plus 700. And we start seeing the pattern pretty quick here. Every time we add 50 gallons, because 50 times 8 is 400, this is going up by 400. So 2300, 2700. Now I need to make a reasonable scale to go with it. Down at the bottom. Well, first of all, who goes where? The horizontal scale at the bottom. G's or W's? The G's, the gallons of water. That's what everything depends on. So label it. Gallons of water. I've got a bunch of boxes here. Oh, 12, 15 of them. And I need to go from 0 to 250. We went by 50s on our table. How about I just go 0, 25, 50, 100, 150, 200, 250, just like we did before. Now this time I'm filling from 0. Well, I'm not going from 0. The tub itself starts at 700 pounds. But I have to go up to 2,700. You want to do the little lightning bolt and start at 700? Do you want to just start at 0 and say, yeet? Okay. Start there. Okay. I'm hearing start at 700. Doesn't mean you had to. If I need to go from 700 up to 2,700, That's 2,000. What should I count by?
Hundreds?
Okay. If I go by 100, well, 2,000 divided by 100. Need 20 boxes. If you got a big enough graph, you can do that. Go by 200s. Okay.
Because then you'll have
And all of those are correct, right? If you've got enough room, you can do whatever scale you need to. I do like the idea of going by 200 or 400 because we kept adding 400 gallons every time. So I do like that idea. I'm going to go with the 200. It feels good. Oh, 29. Okay, fill it in. Orange. Don't you dare. Plot your points. 0, 700. 50, 1100. 100, 1500. 1900. Oh, hell, I missed one. Missed one, y'all distracted me. Plot them in. 1900, 23, and 27. Congratulations. Okay. We're going to make sure that you have a homework assignment on this.